Thank you.
Yes, Salman, you have a question? Yeah, it doesn't help. Every time it happens. I know. I also. Yeah, I know. You want more time? But you didn't start to watch. Yeah, I know there Okay, let's, yeah. Yes, tell me. Louder, louder. Like the way you fight. 2 hours? Oh my God. 1.5, I'll finish. You also ready? I don't know. Can you tell me? Just check, yeah. What about your score? Did I tell you your score? No. Did you log in? How did she check her score? Yeah, please help me. You should check your score, mine. See, buddy. I think you should see. Whenever you solve, go for it. Square root like this. Yeah.
For one question, there were two answers.
Oh, what did you think?
My first is
But it is 4. It's not 4, 5. Yeah, I know. Yeah. Good. Okay. Guys, come back. Let's discuss this first now. See, in the previous classes, what we have discussed is the graphical interpretation of the knowledge that we get from the equations, okay? Now what we will be trying to do is studying each and every graph separately and trying to understand what information do we get conveyed from these graphs, okay? So the first type of graph that we have is a position time graph. I think we discussed this yesterday as well. I told you, what is the rate of change of position called? We say, what do we get? Yes? The rate of change of position is velocity, isn't it? And you find it by rate of change of displacement, isn't it? So whenever we have to find velocity, I told you yesterday, we get it from the slope of which graph? Position versus time graph. Is that clear? Is that clear? So, position time graph. Whenever the graph is position time graph, the first information that you can get from this graph is from its slope, you will get velocity. Is that clear?
Yeah.
Now, if the slope is positive slope means the line will be inclined, isn't it? Positive slope. When the slope is positive, the velocity will also be positive. Is that clear? So velocity will also be positive. When the slope is negative, that means your line will be dip, isn't it? In that case, your velocity will be negative. Is that clear? And if there is no slope, as yesterday we discussed it, if the line is horizontal, it is parallel to the base, then there is no velocity, isn't it? Because position time graph, there is no slope of this line, so there is no inclination. When there is no inclination, there is no velocity. Khalas, that's it. That means the body is at rest. Is that clear? So look at this graph and try to understand what all is happening. See, in this graph we have three parts, isn't it? First, the graph is going up, then it is very much horizontal, and then it is decreasing, isn't it?
Yes.
Yes? So if I tell you, in the first half, in the first part, from O to A, what is happening? It is straight, isn't it? At every point the slope is constant, isn't it? And at every point the line is going up. So when the line is going up, it means positive slope. And the slope at every point is same, therefore it is constant. So can I say in the first half, that is from O to A, the velocity is positive and it is constant?
Yes.
Yes or no?
Yes.
Is it clear? In the second half, what is happening? Is there any slope?
No.
So position time graph, there is no slope. So that means there is zero velocity, isn't it? So the velocity is zero. And when the velocity is zero, you say that the object is at rest. Is that clear? And now look at the last portion. For example, from B to C. See what is happening. Do you see the line is falling again?
Yes.
When it is falling, is the slope negative? When the slope is negative, what is the value of velocity? Will it be positive or negative? It will be negative. But is the slope same at every point? So is the velocity constant? It is variable, isn't it? Now you have to understand, variable means change, isn't it? So can you tell me, if I select this point here, this point is 1, and then I select one more point here, this point is for example 2. Can anyone tell me where do we have more velocity and where do we have less velocity? Yes?
Position 2 we have more velocity.
At
Position 2
position 2 we have
more
more velocity, at position 1 we have
less.
less. Anyone else? Anyone else? So first of all, do all of you agree from B to C velocity is negative?
Yes.
Do all of you agree that the velocity is continuously changing?
Yes.
Is it? But tell me, from the graph, position time graph, how do we get velocity? From the slope. Can you tell me where do we have more slope? At 1 or at 2?
1
At 1 we have more slope. When the slope is more, it means more negative. Negative because it is decreasing, first of all, understand that. So it means at point 1 we could have had negative 10 meter per second, okay? And at point 2 it will be again negative, but yeah, it will be less. It will be negative, say 4 meter per second. Is that clear? Now very important thing. If you plot these two things on the number line, it will feel like this is more, this is less, isn't it? But negative is just the direction. By the magnitude of it, we have more negative velocity at 1 and less negative velocity at 2. Is that clear? Is it clear? That's what you have to understand.
So negative 10 is more velocity.
Yeah, negative 10 is more velocity. Because velocity is a vector, negative means decreasing. Is that fine? But 10, the magnitude is more. Is it clear? That is about how you get converted. Now tell me, a straight line with a non-zero slope, where is it? Which part is it? A straight line with a non-zero. It is from O to A.
Oh.
Isn't it? Straight line is a non-zero slope. From A to B we have a zero slope. From B to C we again have non-zero slope, but it is negative and it is not a straight line, isn't it? Good. A line with a slope of 0 indicates? What does it indicate? Exactly, it indicates rest. It indicates zero velocity. Is that fine? It indicates zero velocity. Very good. A vertical line. Okay, now let me go to this. If you have a position time graph, you have a position time graph, okay? And the line is vertical. What does it indicate? What is the slope?
0. On this term, no 0.
What is the slope? What is the slope in this case? Yes? Yes? 0. So the slope is 0, velocity is 0, isn't it?
Yes.
This means the body is at rest, isn't it? But look at this graph.
Change it.
If there is the vertical line, this was a horizontal line, right? Now this is the vertical line. This vertical line tells me from the slope of this graph, what is the slope? What is the value? Anyone?
It's constant, but it's increasing. Like it's going on.
It's changing, increasing.
See, if you look at the graph, it means at this time, the particle was here. At this time, the particle is also here. At the same time, the particle is here. At the same time, the particle is here. Isn't it different positions? Is it possible for a person except Allah Azza wa Jal to be present at several places at the same time?
No.
It's not possible. Therefore, this graph can never be possible because as per this graph, the slope is infinite. That means velocity is infinite. Is it clear?
Yes.
Allahu Nuru Samawati wal Ard. He is present and he is omnipresent. This graph means omnipresent, and this graph is only for Allah Azza wa Jal. That's it. Alas. Because He has the tendency to be present everywhere. This is the same graph, isn't it? Do you get it?
Yes.
For anything, for all the makhluk, for all the creation, it is not possible to attain infinite velocity. You cannot have this velocity. Even light travels at such a speed, but light is not present everywhere at the same time. But Allah subhanahu wa ta'ala is present in my heart, in your heart, in someone else's heart at the same time, isn't it? That's it. So this graph, whenever you see a vertical line on the position time graph, first of all you need to understand that whenever the graph is like this, slope is infinite. And because the slope of position time graph gives me velocity, therefore the velocity is infinite. Is it possible to have infinite velocity? No, it's not possible. Therefore, this graph doesn't exist. This graph is not possible. So this is what a vertical line will suggest. Is that clear? What about this curved line? Yes. When the line is curved, I think I discussed it with you yesterday. The velocity is changing. Very good. It can be increasing or it can be decreasing, isn't it? Okay. Now look at these graphs and tell me what do you get conveyed. See, position time graph. What is this graph? Yes? It's a curved line?
Yes.
What is the velocity here? Less. What is the velocity here? More. So is the velocity increasing?
Yes.
When the velocity is increasing, is he accelerating or deaccelerating? Accelerating, isn't it? See, everything is covered from the graph. So the velocity is positive because the slope is positive at every point and it is positive acceleration, isn't it? Because he has kept the foot on the pedal and the car is accelerating. Is that clear? What about this? See? What is the velocity at this point?
It's increasing.
What about this point? So velocity is less. So velocity initially was more and now it is less. So what do you suggest? What has he done? He's applied the brakes, isn't it? That is only how this can happen. But see, here he was at 10. At this point he's at 5. But both are positive, isn't it?
Yes.
Isn't it? And then eventually what happens? See? It's horizontal line. So what is the velocity here? Yes? 0. Because there is horizontal line, isn't it? So more velocity, less velocity, and then zero. What has he done? He has applied the brakes. Is he accelerating or retarding? He's retarding. Is his acceleration positive or negative?
Negative.
Khalas, that's it. Negative acceleration, positive velocity. Is that clear? Is that clear? See, how much information does a single graph convey to you? Equations won't tell you this much. You need to have a bunch of equations, then only these things will get conveyed. But from a single graph, everything is conveyed. Now come here. What is happening to the slope of this graph? Decreasing, isn't it? See, what is the slope here? More? What is the slope here? Less, isn't it? Now tell me what is happening. Here the velocity was negative 10 meter per second, and here the velocity is negative 5 meter per second. Now tell me, is his velocity increasing or decreasing?
Increasing.
If the direction is fixed,
It's increasing because it went from 10 to 5.
Increasing. Yes, it's increasing.
it's increasing. He was at negative 10. Okay? Now he is going in the positive direction. Is that clear? See what is happening. This is x, okay? So he has started from some point and now he is coming back because x is reducing with time. The displacement is reducing with time. So that means he is coming back. He was at negative values, okay? Now he is coming back. He was at positive values, now he is coming back, okay? When someone is coming back, he has to increase his speed to come back, isn't it? So his speed in this case, what is happening is his velocity from negative 10 reaches to negative 5. So that means what? That means his velocity has increased. How will the velocity increase? Velocity will increase by pushing up the accelerator or putting up the brakes. Yeah, that is positive acceleration. Or if you don't understand this, you know that acceleration is equal to, yes, final velocity, negative initial velocity divided by time, isn't it? Yes or no? What is the final velocity? It is minus 5, isn't it? So you take it negative 5 and then subtract from it the initial velocity. What is initial? Negative 10, so you can take it negative 10 and then divided by time. Time is always positive, there is no doubt about time, okay? So see what is happening to the numerator. Negative 10 into negative means positive 10?
Yes.
Positive 10, negative 5. Answer is positive.
Yes.
So acceleration is positive, isn't it? So the acceleration is positive, that means the body is accelerating. Okay? Okay? And one more thing. At every point the slope is negative, isn't it? At every point the graph is declining, right? And therefore the velocity is always negative. So when it goes from more negative to less negative, acceleration is always positive. Is that fine? Is that fine? Okay, now look at this graph. Look at this graph. Initially, if you want to check the velocity, here it might be 0. But then it is negative, isn't it? Here it is more negative, isn't it? So it means if it was negative 5 here, what is the value here? Negative 10. From negative 5, the velocity has reached negative 10. Is it retardation or is it acceleration? You have to check the acceleration, right? How do you check the acceleration again? Yes? Final minus initial. What is the final value? Negative 10. And then subtract from it what? Negative 5, isn't it? And then divide by time, correct? So the answer would be negative 10 plus 5. So it is what? Negative 10, negative 5. So the answer is negative. So negative means acceleration is negative. Is that clear? When acceleration is negative, and one more thing, at every point you are seeing that the slope is negative, therefore velocity is negative. Is that clear? This is the information conveyed to you from the graph. Now, to keep it very simple for you, when ever you see a graph in which the graph is concave up? Have you seen concave face of the spoon? This. Whenever the graph is like this, it's always positive acceleration. And whenever the spoon is like this, convex up, that means you are sad. Okay? In that case, it's always negative acceleration. See? Isn't it being sad? And isn't it being happy? So that's it. A smiley face, always what? Keep it, remember it for the rest of your life. And when it is a frowny face, when you are sad, it is negative acceleration. It is simple. When you are sad, you have negative energy. When you are happy, you have positive energy. Can we keep it that simple? Yes? Okay. Now, can you look at this graph, all of you? Do you want to copy this? Yes? Okay. Now look at this graph. There are some points marked A, B, C, D, E, F, G. Okay. I want to know what information do you get from this graph? This is a position time graph again. Okay. The first question that will be asked is, where is the velocity positive and constant? Where is the velocity positive and constant? Positive and constant. Yes? Yes, Salma? D, E.
CD.
A, B, no, it's A and C.
A and
C.
anyone else?
A, B.
A, B,
CD.
C and
C and D. C and D.
C and D.
No, A and C. A and D. A. Zero.
C. C, C. No, you need to understand the question. The question is, where is the velocity positive? Velocity positive means the slope has to be positive. Because which graph is this? This is displacement time graph. This is position time graph. From the position time graph, you will get velocity from its slope, isn't it?
Yeah.
Now he is saying it has to be positive. So slope should be positive. Which portions on the graph show the slope to be positive? It shows A exactly. B is also there. C is also there, isn't it? And nowhere else do you see positive slope. But the question is, it has to be constant. A, khalas. B is changing, isn't it? C, it is also changing. It's not a straight line. It has to be straight. Is that clear? Yes, very good. When is the object at rest?
D.
D, E, exactly. It is E. At E, the object is at rest. Is that clear? Because the slope is 0. Is that clear? So yes, what about where is the instantaneous speed greatest? The point at which the speed is maximum. It will be a point where the velocity, where the slope is maximum, isn't it? Out of all the points, where do you see? B? Yes? F?
Negative direction.
Where is the speed maximum?
Can it be in the negative direction?
Someone is saying B.
G.
Yes?
B or G?
B or?
G.
B or G. If you are saying G, why not F?
So the
G and F, they have same slopes, isn't it? F and G, they have same slope. It is negative, but it is same, right? If you say F, you have to say G as well. If you say G, you have to say F as well, isn't it? The question is, where is the instantaneous speed greatest? He is not telling you about velocity, he is asking you about speed. This is the biggest mistake that you do. You do not understand the question. Speed is never negative. Speed is always, so we have to look for the positive slopes only. It is D, simple. Because at D, when you check the slope, see? Okay? When you check this at C, C is a little flat, isn't it? Is that clear? Yes. So there is only one point. See, you need to understand, it was not velocity. If it was velocity, then we could have taken F or G as well. Is that clear? But he's saying speed. Speed is only positive. So it is at clear? Where is the speed undefined? No. Where is the speed undefined? We cannot define speed at. No. The problem is, see, we have to again talk about this point D. Because this point D, if you look at this point, this is somewhere here, see? This point is here, isn't it? Isn't it?
Yes.
If you consider this D a part of this portion, then the speed is greatest. Isn't it? But if this D is a part of this, then it is 0. So it is very difficult to say where does D belong, right? Therefore, we will not consider D as a point where we have a value. We will always be in doubt about it. So the point where the speed is undefined is D. Is that clear? Where is the acceleration 0?
E.
E?
Yeah.
Why?
It's not moving.
Because velocity is
When velocity is 0, acceleration is 0, so E is there, very good. But what is the definition of acceleration? The velocity change should be, there should be no change, right? There should be no change. In which part of the graph do you see velocity is not changing? A?
E, F.
G.
No, it's constant, not zero. E.
Acceleration is 0. Acceleration will be 0 when the velocity is constant. Do you see in part A velocity is constant?
No.
Yes, A is also the answer. Do you see in F the velocity is constant? Do you see in G velocity is constant? So again, when the velocity is constant, acceleration will be 0. So it will be E, A, F,
G.
and is that clear? See from a single graph how much information was hidden. Clear? Okay. Okay, now we have another graph.
Mister,
Yes?
I had a question about the previous question.
Yeah.
I don't understand how you can have the greatest instantaneous speed, but the speed is also undefined.
Where in the, at this point?
For the
Yeah. See. For the point D, if I put up the eraser. For the point D, this point has the maximum slope. Is it? At the same time, it lies on the horizontal surface, right? So if we take D as a part of this portion, then as for that, it has the maximum slope, because from this point to this point, the graph is something like this, see? Isn't it? So at this, if the D is this lies on this part, then D has the maximum slope and therefore the speed is maximum. Is it?
So why didn't you take it as part of?
That is the problem. If we take it as a part of this horizontal line, at that instant we have to consider that D is also horizontal and therefore the slope is 0. And therefore, now we are in doubt. So D is a point. First of all, it is a point where it is undefined. Clear? No problem in that. Now, if you have to find the point where it is the greatest, which other point can you see? If it is not D, can you distinguish between B, C or A? because he is saying that the speed should be greatest. So we have to check the slope. We have this portion A, we have B here, we have C here, and we have the last point D here. They are the only points where speed is positive, is it? And among these 4 points, which is the point with the greatest slope? It has to be D, right? Isn't it? Which other point do you consider? C, but how come? C is here. I'll tell you. C is here. D is here. Now, at C, if you draw the tangent, it is something like this. At D, when you draw the tangent, it is something like this. Slope is more for D. Isn't it? That is the problem. Either the point D should not have been there. Then we could have, had a competition between A, B and C. But D is a point on the curve. And this curve is not straightening as well. If it was like this, see, if it was like this. If it was like this, C is here and D is here. Then clearly C has more, isn't it? Isn't it?
Yes.
Because at D the slope would have been here and at C it would have been more. But the graph is not like that. The graph is like this. C is here and D is here. Therefore, there is a problem. If the graph is something like this, then of course it is C. Clear? Okay. Now come to this question. There is again a displacement time graph given. So the first question that he asks is, find the total displacement. What is the total displacement? Yes?
Area under graph.
It is displacement time graph. So the time starts from 0. After 2 seconds, body is at 40, okay? And then from 2 to maybe 3, the displacement remains the same. And then the displacement is getting less, and finally it is at 20. The question is, what is the total displacement? 20, of course. There is no doubt in that. See, this is the reference. With respect to reference, body is at 20, isn't it? So the displacement is 20 meters. What is the velocity at t equal to 1 second? Yes. What is the velocity at t equal to 1 second? We have to find the velocity at this point. That means what? What do we have to do? No. See, that's what I said. You have to understand from the graph. Yes. What do we have to find? We have to find the velocity at t equal to 1. Isn't it? So that means the point will be somewhere here. So for this point, if you have to find the velocity from this graph, how do you calculate that? Slope. So we have to check the slope of this line. Is that clear? Do you know what is slope?
Yeah.
Slope is tangent of the angle, isn't it? So if this is the angle here, let it be theta. So tangent of this angle is how much? Tangent of theta, yes? It is perpendicular by base, isn't it? Tangent of theta. Perpendicular by? So perpendicular is 40. And base is? What is the base? 2. Isn't it? So the answer is 20 meters per second. Because for whole from 0 to this point, the slope is same, isn't it? So if you find the slope of this line, it will be same at every point. Yes?
So why is the base 2 if you're talking about 1 second?
Yeah, because I'm not considering the velocity at this point. I'm considering the velocity, I'm considering the distance 40 meters, which is here. So the triangle that I'm using is this. Is that fine? It is perpendicular by base. If you could, see, there is one more thing. You find the velocity at this point, or the displacement, which is say 20, isn't it?
Yes.
And then divided by 1, 20 by 1, again 20. Because this is a straight line, slope everywhere will be same. Is that fine? The velocity at t equal to 8 seconds, t equal to 8 seconds. Yes, now what we are supposed to do? We have to find the slope at this point, isn't it? But do you think that this line has same slope everywhere?
No.
Again, yeah, it has.
Yes.
Isn't it? It's straight. So what we will do is we will draw another triangle. The triangle will be something like this. Is that fine?
Yeah.
Now this is the angle theta. Again check what? Tangent of theta. Is that fine? So tangent of theta is how much? Perpendicular upon base. What is the perpendicular? See, it is 40 here and it is 20 here. So how much is this?
20.
Very good. So it is 20 upon the base. So how much time is this? 5, 6, 8 and 10. So 5 to 10 is 5.
4.
Yes. So the velocity, it is not 4. It is not 4. It is how much? Array, what is the slope from this point to this point? Is it positive or negative?
Negative 4.
So it is negative 4. We found the magnitude. But you have to understand, he is not asking us about the speed. He is asking us about velocity. Is that clear? Has to be negative 4. Clear? When is the velocity 0? If I name this O, A, B, C, from A to B, exactly. Is that fine?
Yes.
Very good. The average acceleration from 5 to 9. The average acceleration from 5 to 9. 5 to 9. 5 to 9. What is the acceleration? Define acceleration. Change it. Is there any change?
No.
Khalas, 0. Why do you get confused? So acceleration is 0. Is it clear? Is there any doubt? Okay. Now this was about the position time graphs, okay? So position time graphs, slope will give you what? The velocity, okay? Now you have another type of graph, that is the velocity time graph. We have what? The velocity time graph, okay? Now when you look at the velocity time graph, again the same thing. From the slope of velocity time graph, you will get acceleration. If the acceleration is positive, the slope will be positive. If the slope is negative, it will be retardation, it will be negative acceleration. Is that clear? Now look at this graph, see? Look at this graph. Velocity time graph, very important. From O to A, what do you think? What is happening? The velocity is increasing, isn't it? But is the slope constant? When the slope is constant, positive acceleration. Is that fine? From A to B, what is happening? Yes? The velocity is constant. When the velocity is constant, 0 acceleration. Okay? From B to C, what is happening? Now, first let me break it again. Let this be C and let this be D. From B to C, what is happening first? The velocity is decreasing, isn't it? So finally it is at rest. So the slope is constant, so it is retardation, isn't it? Because it is decreasing. But from C to D, the velocity is increasing in the opposite direction. Is that clear? Is it acceleration or retardation? It is acceleration in the opposite direction, or in general you can say it is retardation. Is that clear? And then from D to E, what is happening? The velocity is again increasing, although it is negative. It is negative 10 here, it is negative 5 here, it is 0 here. So it is increasing, isn't it? It is again acceleration. Is that fine? So that is it. When the slope is positive, velocity is increasing, isn't it? So it means positive acceleration. When the slope is negative, velocity is decreasing, so it means retardation or negative acceleration. When there is no slope, velocity will be constant. When the velocity is constant, you know 0 acceleration. Is that clear? Now, speed may be increasing or decreasing depending on the velocity sign. Okay? Now, speed, the absolute value of slope. Whenever you are asked, for example, find the speed, find the velocity, Remember, it is at a particular instant of time. Because whenever we ask about speed, we don't talk about average speed. We talk about instantaneous speed. We talk about instantaneous velocity. Is that fine? Okay, if the graph is approaching the x-axis, the object is slowing down, that means speed decreases. Look at this graph. From B to C, is the graph approaching the x-axis? Yes. So speed is reducing. Okay? But speed is positive, isn't it? Speed is always positive, remember this. Speed is positive, but it is decreasing over time, so that means it will come to a stop. Is that clear? Velocity is positive and getting less positive, or negative and getting less negative, that is it. That is the same thing that we have conveyed. Velocity was positive, it is getting less positive, isn't it? Or it is negative and getting more negative. Velocity. See here, it is -2, but when you go down, it is -5, isn't it? Velocity is increasing in the opposite direction. Is that fine? Or you can say it was less negative, now it is more negative. Is that clear? Again the same thing. If the graph is moving away from the x-axis, the body is speeding up. See, from O to A, what is happening? Body is going away from the x-axis, the body is speeding up. Speed is increasing, velocity is increasing. Is that fine? It was less positive, isn't it? Less positive. But here it is more positive. So from less positive to more positive. Or, very important thing, from more negative to less negative. Is that clear? That's again speeding up. From more negative to less negative, because here it is -10, here it will be -5, here it will be -2. So from -5 to -2, speeding up. Fine? That is also increase in speed. Okay, now very important thing. From velocity time graph, you get two things. How many things? First, from the slope you get acceleration. From the slope, what do you get? But if you take the area of velocity time graph, what? Area. Then remember, if you take the area will give you the speed, the displacement or the distance, depending on is it 1D or 2D. Okay? So for example, you have a velocity time graph. If you are asked to find acceleration, find the slope. If you are asked to find the distance or displacement, find its area. Is that fine? So remember this thing. The area of the under the graph will give you what? The displacement. Is that fine? Whenever velocity time graph is given, its area will give you displacement. Whenever speed time graph is given, its area will give you distance. Is that clear? Or both can be calculated from the same graph. No issues. Is that fine? We'll have a numerical which we can solve so that we can find both things from a single graph. Is that clear? That is it. Is there any doubt? Anything that you want to ask? Look at this graph. Look at this graph. This is the velocity time graph, okay? Find the displacement of the object after 55 seconds. Can you solve this? This is a velocity time graph. What are we asked to find? That is, how do you get the displacement? From the area. Up to what time? 55. So we have to find the displacement up to this 55 seconds. Can you tell me how do you find it?
Using the area for the positive and then the negative.
Okay. And then?
Subtract.
Subtract. Yes, exactly. Because this portion is, isn't it? And this portion is? So we have to subtract them. Is that clear? Try to find the area and give me the result. Just What is the area of this portion? What figure does it make? Yes? It is a trapezium, right? Do you know how to find the area of a trapezium? Yeah, half of sum of parallel sides into perpendicular between them. Yeah. See, say this, I'll mark the points. This is O, A, B, and then this is C. This is maybe D, and then this is, say, for example, E. Okay. So if you are asked to find the displacement of the object, so there is some positive displacement and then there is some negative displacement, and you are seeing from the graph positive looks much more, so overall answer will be positive. Is that fine? So how will we do that? First we find the displacement which is positive, okay? And the positive displacement is OABC, isn't it? Isn't it? So what is the area of OABC? That is area of OABC. Okay? Now that area will be given by half of, yes, sum of parallel sides. What are the two parallel sides? AB and OC, isn't it? So it is AB plus OC multiplied by the perpendicular distance. What is the perpendicular distance between OC and AB? Yes? Is it from this point to this point? Yes? How much is that? So I can write it as H, okay? Similarly, you have to find the negative displacement. So negative displacement will be the area of this graph. Is that fine? How do you find the area of a triangle? Half times base into height. So yeah, that would be half of base is how much? Base is CE, and then you multiply it by the height. What is the height? Height is this. Isn't it? Let this be H dash. Now put the values and tell me the result of positive and negative. Yes? No, you don't need to take the height negative. Take it positive. The answer is negative. You know that. So AB plus OC, how much is AB? See, this is 15, right? So A to B is 5, O to C is 30, so this is 35, into height is 60. So it is 35 into 60 upon 2. This is the positive part. Tell me the answer. 1050 for the positive one? Okay. Final answer is? 1050 for what? The first word? Okay, this is 1050. And what about this? What is CE? CE is 30 to 55, so it is 25. 25 multiplied by 40. So it is half of 25 multiplied by 40. Now what is this? Is it 500? So it is 500. Now see, very important thing. How much positive? 1050? How much negative? If he asks you displacement, subtract the 2. So the answer is 550. So for displacement, the answer is only 550. Is that clear? But when he is asking you, find the distance, you have to add that. The answer will be 1550. Is that fine? Clear? Next, find the acceleration and the speed at 30 seconds. Here. What is the acceleration? Displacement, what did I say? Displacement is the effect. So there is, see what has actually happened. This body was here, so it had some positive displacement of 1050, and then it is coming back, negative of 500. Overall, positive. How much? 550. But the total distance has to be added, right? That is why it is 1550. Clear? Now, for the C, D and E part, tell me. What is the speed at 30 seconds? Speed at 30 seconds. 30 is this. 0. Yes. But what is the acceleration? What is the acceleration? Yes. See what is happening from B to C, B to C, and from C to D. Do you see this as a straight line?
Yes.
The slope of this line will give me acceleration, and that will be same for C as well, isn't it? Yeah. So understand. I told you, even if the velocity is 0, doesn't mean acceleration will be 0. So acceleration is there. Because acceleration is the change in velocity, okay? So the change in velocity is how much, yes? See, how do you find it? What is the velocity here? Negative 40? Subtract. What is the initial velocity? 60. And this is positive, right? Isn't it? And then you divide it by the whole time. Final minus initial divided by time, isn't it? So that will be the slope of this line. So how much is the time? From 15 to 40. How much is the time? Yes? 15 to 20 means 5, and then so it's 25, right? Now tell me the result. Negative 4. It should be negative, isn't it? Why? Because the slope is negative, correct? That is it. So acceleration is negative 4 meter per second squared, but the speed is 0. So there can be a possibility when body has 0 speed, 0 velocity, but it has acceleration. Because acceleration is because of change in velocity and not because of velocity. Is that clear? Okay, name the time, just the time, when the velocity is increasing, but the speed is decreasing. Velocity is increasing, but the speed is decreasing. Yes. Velocity is increasing. Just do this. Velocity is increasing, speed is decreasing. Speed is decreasing means? Because speed cannot be negative. You know that. So the question is, when is the speed decreasing and the velocity is increasing? B to C? What is happening from B to C? Is the velocity increasing or decreasing?
Is it D to E? Because it's increasing.
Oh no, it's either D to E or
D to? D to E, what is happening? The velocity is decreasing and?
Is it decreasing?
no, it will be increasing because it's negative 4. So negative
Be very smart. Try to understand what is happening. See, what is the velocity at D? Negative 40. What is the velocity at E? 0. So velocity is increasing, isn't it? And what about the speed? The magnitude here was 40 and the magnitude here is 0. So it is slowing down, isn't it? So yes, it is from D to E. Is that clear?
Yes.
And what about the last one? Name a time when the velocity is decreasing, but the object is getting faster.
C to D.
Velocity is decreasing.
It's B to D. We have to take the whole time.
Yes. I think this should be your homework. Is that fine? Think about it.